Okay, so we're going to do a video here on measurements, and this time we're going to talk specifically about reliability and significant figures. Can you shut that door, please? We're going to, obviously this could be two separate videos, but I think I can keep it pretty short. First of all, reliability. What do we mean when we write a number? So you're, in your textbook, you're given a set of data to lead this section out. About, I think, carbon monoxide levels over major cities in the U.S. over particular periods of time. And so you might be given a number like 14.3 parts per million. What is meant by that? Is this the same thing as 14.300 parts per million? Right? That's the question that's given. And the answer, of course, is not the same thing. So what we mean by this is that we know that this number is 14.3. It's greater than 14.2. It's greater than 14.2 and less than 14.4. That's what we mean by that. If a scientist writes this number in a report, that means we know it's between these two numbers. It's greater than 0.2 and less than 14.4. And we also know that if no plus or minus is given, then it's going to be plus or minus, in this case, 0.1, right? Plus or minus 1 unit of the last level of precision. Okay, so this is 10th place, so it'd be 14.3 plus or minus 0.1. All right, that's what the uncertainty is. What this plus or minus means is another question which is outside the scope of this course. Okay, so that's what reliability is. Let's practice this a little bit and we'll move on to sig figs, okay? So look at this syringe right here. This is a 10 ml syringe, and the question is, what would if you were measuring some liquid inside here, and the plunger, the top of the plunger, was say right on that line right there? What would it be if it was exactly on that line? Okay, well obviously it's greater than 2 and less than 3, right? Can you see that? So it'd be 2 point something. Okay, and there's 1, 2, 3, 4 lines in between these two. So each of these is 1, 2, 3, 4. 1, 2, 3, 4. Okay, yeah. 2.2, 2.4, 2.6. So this is 2.6, but you have to estimate now. So if it's exactly on that line, you would say it's 2.60. Okay? 2.60. Because you have to estimate one digit past that point. Let's do one more, and then we'll move on. So they brought a beaker with me too. This beaker's a little bit flat, but I thought it'd be easier to see underneath the camera if we just used a flat beaker instead of a round beaker. So this beaker has got these measurements here on the side, and a student behind me walked up and wanted to look at this flat beaker. What does a flat beaker look like? This is a flat beaker. I can just put my hand across there and it doesn't even bump up at all. Look at that. So let's suppose we've got a liquid in here and it goes up to that level right there. Okay? Pretend this little wavelets. Alright. So what is this measurement? Okay, so you can see that that's 60. It's going to be in mils. Alright, milliliters. 60 mils. So it's going to be greater than 60 mils but less than 80. Right? So your job then is to say where it is between these two. They are 20 mil increments. Okay? And so we're going to say it's a little over halfway between there. I'm going to say it's 1/6 of the way up. 1/6 of the way up would be 60 point... I can't do this in my head. No, it's 70. Sorry, greater than 70 is over halfway to 80, right? So it'd be 70. Just a second here. What's 1/6 of or rather, what's 6/10 of 20, right? That would be 12. So that would be 72. 72 mils. Okay. And since you see that this is we're going to estimate that last digit. So what we're saying with this reliability is that that last digit is our digit of estimation. That's what are meant by those numbers. Okay, so there's more examples to do in the book, but I wanted to at least speak to the issue. And the next thing I want to do and go over a little more thoroughly is significant figures. Alright, so sig figs. Well, there are several rules for sig figs. First of all, non-zeros and zeros. Okay, so two categories of rules. But if you've got a number, I said 14.3 for example, all non-zeros are significant. That's the term we're going to use, significant figures. How many sig figs does 14.3 have? Well, it's got three numbers that are non-zero. Okay? And so it's got 3. Okay? What about 42? How many sig figs does that have? 2. Well, let's run down the paper here. Okay? 42. What about 113? That's got 3 sig figs. Okay, right? Because there's 3 non-zero digits here. Okay, what about zeros now? Nested zeros are all significant. Okay, so 103 has got a 0 in between, right? So it's got 2 non-zero digits, but it's got 1 in between too. So it still has 3 sig figs. Okay, what about 1003? Well, both of these zeros are nested between non-zero digits, and so it's 1, 2, 3, 4. 4 significant figures. Okay, what about leading zeros? 0, 0, 1. Any leading zeros are insignificant. Okay? That, of course, not numbers just 1, but let's say we've got a number that looks like that. Okay? You've got, obviously, 3 zeros, but those zeros are just placeholding zeros. They're really just showing you what the magnitude of that 1 is. Right? If we use, say, a micro or a milli here, we could get rid of those altogether. So it turns out these leading zeros make it a 1 sig fig. Leading zeros are insignificant. I'm going to put sig not. Okay? What about trailing zeros? Okay, trailing zeros, 100. Well, a trailing zero if it's just showing the magnitude and it's before the decimal point, you see that? But it's just showing the magnitude, it's insignificant. So I'm going to say sig not if it's before decimal point and not showing the decimal point. Okay? You see that's a trailing zero. Now let's do another one. That's got only 1 sig fig, right? Let's do another one. How about 110? How many sig figs does that have? Well, it's got a trailing 0, but that's only showing how far this tens place is away from the decimal point, right? So it's got 2 sig figs. That is not a significant figure. Okay? What about trailing zeros after the decimal point? They're significant. I realize my handwriting is horrible here. But a trailing 0 after decimal point, like 11.0, okay, that's definitely significant because it's a trailing 0 after the decimal point, and it's significant. So there are 3 sig figs with that. Okay, let me point something out here, though, that there is an implied decimal point here, and that's the term that your book uses here. It's an implied decimal point. Okay, if we have an explicit decimal point, and Trost says the same thing I said in class, if it's an explicit decimal point, I'm going to go back to before the decimal point. It's significant if it's explicit. What do I mean by that? Watch this. 110 point. You see I've drawn it out. That automatically means that is significant. Okay? So that's going to be 3 sig figs. Okay, I don't want to say any more about that right now. By far the best way to get significant figures, by far and away, the best way to get both of these is to simply do practice. Okay? So we've got homework problems. We'll be doing those. We'll be doing problems in class. and I hope that's useful. But frankly, I'm not really expecting you to like it until you do a bunch of problems. So good luck. Let me know what I can do to help you.